Hi everyone. Now we're at the point where we can really start getting into some free response questions that show up on the AP exam related to all this graph sketching content. So that's what we're going to be working on when you're back in class. So this video is just to give you kind of an example of what this might look like if it shows up in an FRQ on the AP exam. So this is going to be a basic example, but we just want to walk through kind of how this should look, what your justifications should look like, and make sure we have all the pieces that you need to get full credit on the exam. So we're going to be analyzing the graph of f prime, and this is a question that was on the 2000 AP exam. So it says the figure above shows the graph of f prime. So again, the first thing I'm noticing here is that I have the graph of f prime. Obviously, that's going to be really important to make sure I'm answering these questions correctly. So the first thing I'm looking for is to be very clear on whether I have the graph of f or the graph of f prime. Okay, so we have the graph of f prime, which is the derivative of the function f, on the interval from -7 to 7. So I know I'm working on a closed interval here. Okay, so now it says the graph of f prime has horizontal tangent lines at x equals -3, x equals 2, and x equals 5. If I have a horizontal tangent line, right, that tells me that at those points, I'm going to make a little note here, f double prime is equal to 0. If I have a horizontal tangent line, f double prime is equal to 0. And then it tells me I have a vertical tangent line at x equals 3. Now, if I have a vertical tangent line, it means I'm not differentiable at x equals 3. So it tells me that f double prime of 3 is undefined. Okay, so notice, I kind of went through all of that before I even looked at the question. So I'm just trying to get as much information about this graph as I can. So now, in part A, it's asking us to find all values for x between -7 and 7, not inclusive, so I don't need to worry about those endpoints, at which f attains a relative minimum, and it's asking us to justify our answer. So, if I'm looking for a minimum, I know that's where f prime changes from negative to positive, right? From above to below the x-axis. So if I look, here I'm changing from above to below, or excuse me, this is from below to above. So here I have above to below. Here at -1, I see I'm changing from negative below the x-axis to above, which is positive. So that's going to be the location of my relative minimum. So I would say, and now here I always answer in full sentences. So f attains a relative minimum at x equals -1. So that's finding the value of x where it happened, and now I have to justify it. So we're just going to justify it using exactly what we said here. So it attains a relative minimum at x equals -1 because f prime changes from negative to positive at x equals -1. So they're just looking for you to justify that using that first derivative. Okay, now in part B, they're asking the opposite. So now they want you to find all values of x. Again, this is an open interval, so we don't have to consider the endpoints, okay, at which f attains a relative max. Now, this I know is where f prime changes, in this case, from positive to negative. So f goes from increasing to decreasing. So I see f prime changing from positive to negative here at x equals -5. There's no other point because here it doesn't actually change signs. So the only value I'm worried about is -5. So f attains a relative maximum at x equals -5. There's our location, and again, we're going to justify it using that first derivative. Because f prime changes from positive to negative. At x equals -5. So there we'd get full credit. 1 point probably for identifying where it happens, and then a point for justifying our answer. All right, so now the last part here is asking us to find all values of x between -7 and 7 at which f double prime of x is less than 0, where that second derivative is less than 0. So I know if they're asking about the second derivative, what I really need to find out is where is the slope of f prime negative. So that's what I'm going to look for on this graph. So we're going to go back up here. I can see that I have a negative slope from -7 to -3. Okay, so that's going to be my first interval. So let's go ahead and write that down. I'm going to say f double prime of x is less than 0 on -7 to -3. And let's see where else. Now, my slope is negative. It looks like here from 2 to 5. But I have to be careful. I'm not going to write that as one single interval because we already said that it's not differentiable here at -3 because of that vertical tangent. So that derivative actually doesn't exist there, so I need to break this up into 2 intervals, from 2 to 3 and then from 3 to 5. And again, I'm breaking that up because that derivative, that second derivative, doesn't exist at x equals 3. So we're going to add our intervals 2 to 3 and then 3 to 5. Now, it doesn't specifically ask us to justify it, but I think it's good practice to write that anyway. So we're going to say it's less than 0 on these intervals because, we're going to explain how we know that, the slope of f prime is negative on these intervals. Okay, so this is an example of the types of problem you might see as well as what kind of justifications you'll be required to include on these AP questions. So like I said, when we're back in class, we're just going to give you several different examples of what this looks like on AP exams so you can get used to that format. That's it for today, nice and short.